In the previous lecture, I had explained to some extent the benefit of using dynamic memory allocation. I had cited an example of linked list whereby we can have different nodes, and those nodes they can be created dynamically at runtime. That means whenever the need arises, the user can create new nodes. I have come up with another advantage of using dynamic memory allocation, and that is the use of a library function called realloc. Now, as far as realloc is concerned, it's a very powerful function. Using realloc, what we can do is we can increase or decrease the size of an array which was allocated dynamically. That means if we have created an array using dynamic memory allocation, at the time of execution of the program, we can either contract or expand its size, right? So let me explain it with the help of an example. Here is the declaration of array through pointer notation, and here we are going for dynamic memory allocation using malloc. I have allocated space for 3 int elements. The base address would be put into this pointer variable values, and afterwards using this simple loop I am reading the values into the elements of this array. Now after that I want to increase, that means I want to expand the size of this array from 3 to 5. This is just an example. You can increase or decrease the size to any extent. So see how I am using this syntax of realloc. I am reusing this pointer variable values which was representing our array. int star, as you know, this is being used for typecasting. This is part of the syntax realloc library function. Then we are supposed to write the name of the pointer variable which was representing your array with the earlier size. Now the name of this pointer variable happens to be the same as it is going to be assigned to, right? The names can be different too. Anyways, let me tell you again, this first argument of realloc is nothing else but name of the pointer variable that is representing your current array, right? Then you are supposed to give size of and the corresponding data type your elements belong to, multiplied by the number of elements you want to have. Now when you would write into 5, so your array with the name which was allocated with the name values would be now reallocated the space, and this time over not for 3 elements but for 5 elements. So what you can see is this statement is increasing the size of your array from 3 to 5. So in this simple loop I am going to read rest of the elements. So naturally I would start from 3 because I have already inputted the elements with the subscript 0, 1 and 2 in the previous loop. So c is equal to 3, we have got 2 new elements. So c is equal to 3, c is less than 5. So this loop is again going to read the values, and ultimately I have displayed all the values using this pointer notation. Again, I must tell you, I could have printed the array elements using this conventional method also, right? So let me execute the program, and you can see the results for yourself. So I have read 3 values. These were the values for the array that was for 3 elements. Now after issuing realloc method, the array has been resized to 5. So rest of the 2 elements are getting read, and finally it's printing all the 5 elements.